Solving literal equations. A literal equation is an equation in which known quantities are expressed either wholly or in part by using letters. A good example is s equals d over t, speed equals distance over time, which you may have seen in a physics course. Another example is c equals 2 pi r, circumference equals 2 pi times the radius, which we use when studying geometry. In some cases, it's actually easier to work with literal equations since there's only variables and constants. When solving a literal equation, you will be asked to isolate a particular variable in the equation. For example, with the formula L equals PRT, you might be asked to solve for P. This means that P will be on one side of the equation by itself. The new formula will look like this. P equals L over RT. You can transform a formula to describe one quantity in terms of the others by following the same steps as solving an equation. Let's solve this equation for R. In this equation, capital C represents the circumference of a circle, R represents a circle's radius, and pi is a constant, about equal to 3.14. So the given equation allows us to determine the circumference if we are given the radius. The new equation solved for r will allow us to determine the radius if we are given the circumference. Solving the equation means that when we're done, we'll have r alone on one side of the equation. So, what's the first question? Is r alone? If not, what is currently with it? R is not alone. It's currently with 2 pi. What mathematical operation connects them? Currently, R is being multiplied by 2 pi. What is the opposite of multiplying by 2 pi? Dividing by 2 pi is the opposite of multiplying by 2 pi. So if we divide the right side by 2 pi, what must we do on the left side? If we divide the right side by 2 pi, we must also divide the left side by 2 pi. Is there anything else with r? Don't forget, you can do anything you want except divide by 0 to one side of an equation, as long as you do the same thing to the other side. No, there's nothing else with the r, just the 2 pi. Remember, if there's more than one operation going on, you must undo them in the opposite order in which you would do them, which would be the opposite of the order of operations. Now, let's go ahead and solve this equation for r. All right, as previously discussed, we are going to divide both sides by 2 pi, and you can see that the 2 pi is going to cancel out, leaving r by itself. So we have c divided by 2 pi equals r, and then just flip it around so that it says r equals c over 2 pi. Solve for w. So here we have v equals LWH. We want w to be by itself. So right now it's being multiplied by two other variables, L and H. So we're going to divide by L and H on both sides. And look over here, the L's will cancel and the H's will cancel. And we get V over LH equals W. I'm going to actually make this like a curly L so that it looks more like an L and less like a 1. Boop, like that. And then we're just going to flip it around because we like when it says W equals V over LH. Solve for W. All right, so right now W's here. It's being multiplied by 2 and it's being added to 2L. So PEMDAS is the order of operations. Parentheses, exponents, multiplication, division, addition, subtraction. So when we're undoing operations, we move the opposite direction. So first, we're going to do any addition or subtraction. That means we're going to subtract 2L from both sides first. That's going to cancel out, so we get P minus 2L on the left side equals 2W. Then I'm just going to swap the sides of the equation. 2w equals p minus 2l. Then we're going to divide both sides by 2 to undo the multiplication on the left side. You can leave it like this. You could also make it 1/2 p minus l. So you're dividing each piece by 2. Like you can separate it. Actually, instead of writing it out like that, I don't want to skip any steps. It would be p over 2 minus 2l over 2. See how you can break that up into two different fractions? And then these 2's would cancel. So we have p over 2 minus l. And that's what w is equal to. And here are the solutions. Let's solve this equation for t. This is actually a very common physics equation, a kinematics equation, in which v equals the object's final velocity, v naught, or v with a little 0 subscript, represents the initial velocity, a represents acceleration, and t represents time elapsed. So the given equation allows us to determine the final velocity of an object. The new equation will allow us to determine the amount of time it takes for its velocity to change from its initial to its final value. Solving the equation means that when we're done, we'll have t alone on one side of the equation. So, what's the first question? Is t alone? If not, what's currently with it? Right now, t is with v naught and a. What mathematical operations connect them? Right now, t is being multiplied by a and is being added to v naught. So which of those should we undo first? We use the reverse of the order of operations when undoing. So first, we're going to undo the addition, then the multiplication. As shown above, the first step is to undo the addition of v naught by subtracting it from both sides. So we're going to subtract v naught from both sides. And the v naughts cancel out on the right, and we have v minus v naught on the left. What do we do next? Next, we undo the multiplication by a by dividing both sides by a. Finally, we move t to the left side of the equation, so we're just going to flip the whole thing around. We can now determine the elapsed time given the starting and ending velocities and the acceleration of an object.